Welcome back to the CCNA routing and switching series, brought to you by ABY Design and Tech. You are joined here by your instructor, Abdurrahim Chowdhury, and in this video we will look at the need for the ARP protocol. So let's just cast our minds back to the previous video that, essentially the two previous videos that we've made about switch and MAC and route and IP. Now, just as a side note, IP and MAC, we will go further into how the IP protocol works and how the Ethernet protocol works in later videos. But the videos pre-hand, so the switch and MAC, the route and IP, those were kind of just introductory videos just to describe how those protocols work. Now, like I mentioned, we spoke a little about IP and MAC. We discussed how IP and MAC work together to allow data to travel and get to where it needs to go. However, the question you're probably asking in your mind is, how does a device know what MAC address is associated with an IP address? As an example, when Bob sends that data to its router, its default router, how does it know that the default router has got the IP address 192.168.200.1, and how does it know that the MAC address BBBB is associated with that IP address? Well, as another example, let's say Bob and Brad, let's say they're both in the 192.168.2.110 network. How does Bob know that Brad have the IP address .15, and how does he know that DDDD is his MAC address? This is where the ARP protocol comes into play. So ARP allows a device to resolve IP addresses into MAC addresses. It's a broadcast message. So with IP, there are different types of messages. So what we've been talking about so far, we've been talking about unicast traffic. So unicast traffic is traffic sent from one device to another device. A broadcast message is a message that is sent from one device and is sent to all other devices on that network. Now, it's important to understand that broadcast messages only go to devices on the same network as the device which originated that broadcast. We will learn about this in a later video as to why this is the case. However, this is important for ARP because ARP relies on the broadcast message to be able to resolve IPs into MACs. Now, the analogy we're going to use to explain this. Okay, so let's imagine, so Bob and Brad, they're friends. Bob moved to the US, Brad was still in the UK. Now, for whatever reason, Bob has returned from the US and has actually moved into the same street that Brad lives in. So now Brad, he doesn't know in which house Bob has moved into. All he knows is, okay, so Bob's in the same street as me. Let me find out where Bob lives. So what does Brad do? Brad, he picks up his megaphone, he goes out onto the street, turns on the megaphone and essentially belts out, "My name's Brad, I'm looking for Bob. Can anybody tell me where Bob lives?" Now, the other neighbours, they hear this man screaming at the top of his lungs, asking for this dude called Bob. None of the other neighbours pay attention to it. They're like, oh, forget that. This guy, Brad, isn't looking for me because my name's Rob or my name's Rick. However, Bob, he receives the message. He hears, okay, I can hear Brad. He wants to speak to me. He wants to know where I am. So now Bob pops his head out the window, turns on his megaphone and belts back out to Brad. "Brad, it's Bob. I live on number 13 XYZ Street. So I live in the same street as you. I'm number 13. Now Brad knows which house Bob lives in. And to be fair, ARP works exactly in the same manner. With ARP, what you'll see in the preceding examples is the device essentially shouts out to everybody, "I am looking for the device with this IP address. I want to know that 192.168.200.1, I want to know what his MAC address is. And I'm going to announce this to everybody on the network in the hope that the correct device will actually receive this message. Obviously, if the correct device does, it's going to respond directly back to the sender of the ARP message listing its MAC address. So let's see this in action. So we're going back to our example from the previous video. Bob wants to send an email to Brad. Okay, he says, okay, I've got an email to send to Brad. We're still using the same IP information, and again, just as a quick recap, we know that the network essentially defines which group you are now in, and depending on the subnet mask, will kind of dictate, well, it will dictate what decimal numbers in a device's IP address must be the same for that device to be part of that group. So in this case, we have a 255.255.255 subnet mask, or in prefix format, a /24. Again, when we convert the subnet mask that I've shown you so far into the binary format, it's essentially a set of consecutive binary ones followed by a set of consecutive binary zeros. And in this case, the 255.255.255, that dictates that the first 3 decimal numbers for every single device in this network have to be the same, because it's the first 3 decimal numbers which dictate the network path. So in this case, this is the network that the devices would be part of. But in any case, Bob needs to send an email to Brad. Bob knows, okay, Brad is not my network. I've essentially compared my IP address to my subnet mask. I know that Brad, he lives on a different network, so I know that I can use my router to reach Brad. But then the question that Bob comes to realize, or what Bob comes to realize, is that he knows that his router has got the IP address 192.168.200.1, but he doesn't know what his default router's MAC address is. So Bob's like, aha, let me use the ARP protocol to find my router's MAC address. So essentially, this is what the ARP protocol does. Bob is going to build what's known as an ARP request message. It's going to list the sender IP as obviously his IP address, sender MAC as his MAC address. He's going to list the target IP as the IP address of the default router, and he's going to list the target MAC address as unknown. Essentially what this says is that I know the IP address of the person that I'm looking for, but I don't know what that person's MAC address is. Can you please help me? Now, I've changed the diagram slightly, essentially just to show that there's other devices connected to this network. The ARP message is sent from Bob, is sent out all other active ports on the switch. So essentially everybody on the network is going to receive a copy of this ARP message. Now, they're not all going to respond to it. Essentially, the way it works is that, okay, they're like, okay, I can see this ARP message. I'm going to have a look here. Okay, this isn't for me. Forget about it. That's what they're all going to do. So they're all going to spend a bit of time processing the broadcast message, the ARP request. They're going to realize, okay, this isn't for me. I'm going to ignore it now. So by using a method like this, because Bob doesn't know exactly where the router is, it's kind of he's thinking along the lines of, if I announce this to everybody, then surely the correct device that I'm trying to get to will actually receive this message. So in this case, Bob's right. The router receives this message. So the router thinks, okay, I've received this ARP message from Bob. He is using IP address 192.168.200.10. Looking at this message, he wants to know my MAC address. So now I shall respond directly back to Bob, and this time this is what we call an ARP request message. I'm going to list my MAC address as the sender MAC. So in this case, the router lists its IP address as the sender IP, its MAC address as the sender MAC, the target IP and target MAC address are Bob's IP and MAC address, and even if the default router didn't know Bob's MAC address, it does now because of the original ARP request that the default router received. Because you have to remember that the ARP request Bob sent is going to list his IP address, it's going to list his MAC address. So now using that information, the router now obviously knows that Bob is using IP 192.168.200.10, and he's using the MAC address AAAA. Okay, and then that message is sent directly back to Bob. So now Bob has received the ARP reply from the router. He's thinking, okay, I received an ARP response. I will now add this information to my ARP table, and I now know what my router's MAC address is. Okay, so the next thing you're thinking, okay, what's the ARP table? So let's cover the tables that we've covered so far. We know we've got the MAC address table, which essentially lists each each device's MAC address on the network. This is used by switches. We have the routing table used by routers. This dictates, okay, these are the networks I know how to reach. This is how I get to them. Now we have the ARP table, and essentially what the ARP table does, the ARP table will list every device that Bob knows about. It will list that device's IP address and the MAC address that can be used to reach that device. So in this case, now Bob is going to add an entry to his ARP table saying that, okay, device 192.168.200.1, my default router, has the MAC address BBBB. Now, I'm going to send this email to my default router. So now I have got all the pieces of the puzzle. I already knew my default router's IP address because the network engineer who configured the IP settings for this computer programmed me to know what the default router is. I didn't, however, know what my default router's MAC address. Now that I've got that information, I can essentially add the IP and MAC address information to this email, to this piece of data, and I can send this data on its way towards my default router. And so now that data will flow all the way to the default router. And of course, like we have seen in the previous video, the router is then going to de-encapsulate. So essentially, okay, I can see that this piece of data was meant for me. Let me look at it further. Okay, this email that Bob sent wasn't actually meant for me. This email was actually meant for Brad, but Bob wants to use me to reach Brad. Now, this is a screenshot of what the ARP table actually looks like. So the command that you can use to find the ARP table for your computer, your laptop, etc. is on a Windows machine. You would open up command prompt and you would just type in the command ARP space -A. And so what this command does, it lists all the entries of the ARP table. So in this case, we can see here one dynamic entry where it says that, okay, the device with 192.168.1.254 has got the MAC address 2420C780766BB. A dynamic entry means that I learnt of this IP address using the ARP protocol. Now, let's have a look at what the ARP request and the ARP response look like. So again, this image was captured via Wireshark. We'll go a bit more into depth about how we can use Wireshark to essentially to do some basic troubleshooting. And to be fair, Wireshark is a very good tool, especially when you're studying, because you can see what the actual data looks like as it flows from point A to point B. So in this case, we can see what the actual ARP request looks like. So in this case, this is the ARP request that was sent by my laptop. As you can see, the destination is all Fs. So a destination MAC address of all Fs means broadcast. This means that when the switch receives this, I'm telling that switch, send this out all of your ports to all the devices on the network. The source is going to be my laptop's MAC address. And so this piece of information down here, this portion down here, is going to show the ARP request. So what does the ARP request actually look like? So as you can see, the ARP request lists my laptop's IP address, my laptop's MAC address. It lists the target IP address. So in this case, this is going to be my default router's IP address, but it doesn't list anything for the MAC address because as of yet, my laptop doesn't know what the MAC address is of my default router. And like I said, all the devices on your network are going to receive this ARP request. They're going to look at it. They're not going to respond back because this isn't for them. However, once your default, in this case, once my default router has received this ARP request, he's going to know, okay, the target IP address is 192.168.1.254. Oh my god, that's me. Let me now respond back directly to Abdi's laptop, and I'm going to list my MAC address as the sender MAC address. So in this case, this shows the ARP response. So as you can see, the ARP response, you can see here now, the source address is going to be my default router. The destination address, that's going to be my laptop. This sender IP is 192.168.1.254. Sender MAC is 2420C78076BB. And the target IP and MAC listed is my computer's IP and MAC address. Now that my computer has this information, any website I visit, anything I do essentially which requires internet access, which to be fair is going to be everything from your house, my router, sorry, not my router, my laptop will now have the relevant information in his ARP table to be able to send all the traffic that needs to essentially go out to the internet to my router. And to be fair, that's all there is to it. So as you can see, the ARP protocol is relatively simple. Again, as an analogy, if a device doesn't know the MAC address, which is related to the IP address, it's going to essentially broadcast out the messages and say, hey everybody, I want to find the MAC address of the device with the IP address 192.168.200.1. I'm going to send this to everybody in the hope that it reaches the correct destination, in a similar fashion to how Brad used the megaphone to announce to the street that he's looking for Bob. Everybody heard it, and because everybody heard it, it meant that the chances of Bob hearing it was very, very high. Then obviously Bob responded back. Thank you for watching. If you want to see more content like this, please subscribe to my channel. And like I always say, share this video with as many people as possible so that we can get free high quality training to the masses free of charge. Thank you very much.